Remember that during a chemical reaction, the bonds in one set of substances are rearranged to form new bonds and therefore new substances. Chemical reactions can be represented with chemical equations. Here we have acetic acid, better known as vinegar, reacting with sodium hydrogen carbonate, better known as baking soda, to form water, carbon dioxide, and sodium acetate. These symbols in parentheses after each substance tell us what state these substances are in. Vinegar and baking soda are on the left side of the arrow, which makes them the reactants in this equation. Water, carbon dioxide, and sodium acetate are the products of this reaction because they are on the right side of the arrow. The reactants are the inputs of the chemical reaction. The chemicals that are made during the reaction are the products. Coefficients are the numbers in front of a substance that tell us how many molecules of that chemical are needed for the reaction to proceed. Since there are no coefficients in front of any of the reactants and products, that means we need one molecule each of the reactants and one molecule each of the products. Therefore, one molecule of aqueous acetic acid reacts with one molecule of solid sodium hydrogen carbonate to form one molecule of liquid water, one molecule of carbon dioxide in the gas state, and one molecule of sodium acetate dissolved in water. Our focus for this discussion of chemical reactions involves conservation. Conservation means that even though new substances are formed during a chemical reaction, there are few items that must be the same at the beginning and the end of a reaction. There are 4 quantities that must remain constant. The first is the type of atoms involved. When we analyze the reaction of carbonic acid decomposing into carbon dioxide and water, we could see that we have hydrogen, carbon, and oxygen atoms on the reactant side of the equation, and we have those same elements on the product side, hydrogen, carbon, and oxygen. New types of atoms cannot be formed during a chemical reaction. The amount of atoms on each side of the reaction must also be conserved. This means that the chemical equation must be balanced. Balancing the atoms of each element on the reactant and product sides of a chemical equation is the main purpose of coefficients. To find the total number of a certain atom in a chemical reaction, multiply the coefficient by the subscript. In the reaction shown here, there are 2 hydrogens on the reactant side of the equation. 1 times 2 is 2. There are also 2 hydrogens on the product side. 1 times 2 is 2. Look at carbon. On the reactant side, there is 1 carbon atom. 1 times 1. And on the product side, there is 1 carbon atom. 1 times 1. Finally, there are 3 oxygen atoms on the left side of the equation, 1 times 3, and also 3 oxygen atoms on the right side, 2 in carbon dioxide and 1 in the water molecule. This reaction is balanced. There are the same number of each type of atom on both sides of the equation. We will definitely be spending more time with the practice of balancing equations. So far, we have learned that the type of atoms and the amount of atoms must be conserved during a chemical reaction. You should be familiar with the next 2 quantities that must also be conserved during a chemical reaction: mass and energy. During a chemical reaction, mass must be conserved. No mass can be gained, no mass can be lost. Let's take a look at the reaction between vinegar and baking soda again. If we take care to run this reaction in a closed system, then we should see that the mass of the products equals the mass of the reactants. What do I mean by a closed system? Well, we have to account for and collect all the products that are produced. This is what the balloon is for. The balloon will collect the carbon dioxide gas that is produced during the reaction. A small amount of baking soda has been placed inside of the balloon, and the flask contains about 100 milliliters of vinegar. As you can see, the initial mass of the reactants, flask, and balloon is 184 grams. This means the mass after the reaction is complete should also be 184 grams. The reaction occurs as we shake the baking soda from the balloon into the flask. The bubbles that are produced contain carbon dioxide gas. The gas is collected in the balloon as it is released. As you can see, as the reaction comes to completion, the mass of the products is the same as the initial mass of the starting materials, 184 grams. The last quantity that must be conserved during a chemical reaction is energy. Energy cannot be created nor destroyed during a chemical reaction. Compounds and molecules store energy in chemical bonds, ionic bonds, covalent bonds, and metallic bonds. Breaking a chemical bond requires energy. You must put energy into the reaction. Forming chemical bonds releases energy. Energy is given off to the surroundings as the reaction proceeds. If this sounds familiar, that is because it should. Remember that chemical reactions can be either endothermic or exothermic. The energy that is put into or released by a chemical reaction is necessary in order to uphold the law of conservation of energy. For an endothermic reaction, the products have more energy stored in chemical bonds than the reactants. That means energy must be put in to break the bonds of the reactants. In this example, energy must be put into mercury 2 oxide in order to separate the compound into mercury and oxygen gas. Since energy has to be put in, the reaction is endothermic. Energy is a reactant. For an exothermic reaction, the reactants have more energy stored in chemical bonds than the products. This means that energy must be released upon the formation of the bonds of the products. This example shows the combustion of propane to produce carbon dioxide and water. If you have a gas grill at home, then you already know this process is exothermic. You use the heat released upon the forming of the bonds of the products to cook your food. Since energy is released during the reaction is exothermic. Energy is a product of the reaction. In summary, we have learned that 4 quantities must be conserved during any chemical reaction. The reactants and products have to have the same types of atoms and the same amount of each type of atom. The final mass of the products must equal the initial mass of the reactants. And energy must be conserved. That is why some reactions are endothermic while others are exothermic. That is enough to process for now. So until next time.